Hello everybody, getting ready to do lesson 4.7 part 3 of pre-calculus math today. It will be a classwork session. If you need a classwork sheet, email me here for those or any other course materials. 4.7 part 3, we got 2 points here in your notebook and 46 points goes on your sheet. Today's page 1 for part 3, inverse trigonometric functions. The parent inverse sine function, parent inverse cosine function, and parent inverse tangent function are summarized below. So here is your parent here for arc sine here. Will be the inverse sine function is here. Starts at negative pi over 2, and it goes up to pi over 2, and it's interval negative 1 and 1. That is your range, and then your domain is negative 1, 1, intercept 0, 0 is an odd function, origin in the symmetry. This is your arc cosine here, kind of goes in the opposite direction here like this. Domain negative 1, 1, range is 0 pi, so it starts up here, it doesn't go down into negative pi over 2. But it starts here at 1 and crosses over like that at pi over 2, and then the y-intercept, this has y-intercept at 0 pi over 2, and then the arctan here, the domain is negative infinity, positive infinity, and then the range is negative pi over 2, and then pi over 2, and then the intercept is 0 here. Horizontal asymptotes are y equals plus or minus pi over 2. You got asymptote here and asymptote here. And then it is an odd function because it is symmetric to the origin. Let's get into an example 5 here. Compare a graph of each function with a graph of f of x equals arc cosine x. So g of x equals arc cosine x minus 2. Because g of x equals arc cosine x minus 2 equals f of x minus 2, the graph of g can be obtained by shifting. So here is our original arc cosine here, but we're shifting to the right here because of this 2. The graph of 2 units to the right is shown. So we shift over here, arc cosine x minus 2, so we're shifting over here 1, 2 from the y-axis here. And we're shifting 2 from here over to here. And then we have h of x equals arc cosine negative x. So because h of x equals arc cosine negative x and equals f of negative x, the graph of h can be obtained by reflecting the graph of f in the y-axis. So we have a situation here where the arc cosine is a reflection of this function here, which is arc cosine x. This is arc cosine of negative x. So we have a reflection in the y-axis. So we start over here, and then we cross it so we have the same y-intercept here, which is pi over 2, and then for the original, we start here, and then we end up here, and then over here we start negative 1, and then we end up over here as a reflection in the y-axis. So let's try one. Compare the graph of the function and the graph of f of x equals arc cosine x. So g of x equals arc cosine x plus pi. Down here, arc cosine x minus 5. So up here, g of x equals arc cosine x plus pi is a horizontal shift pi units to the left of f of x equals arc cosine x. So instead of starting here at 1, we shift to the left pi units, which is 3.14 units to the left here, and then we have the same symmetry here on your curve. This shifts to the left 3.14 as well. And then down here, we have g of x equals arc cosine x minus 5 is a horizontal shift 5 units to, instead of going to the left, go to the right. To the right of f of x equals arc cosine x. So instead of pi, we have a shift of pi, you have the shift of 5 over here to the right. So you shift this way 5 units, keeping the original shape of your curve, but shifting to the right 5 units. Composition of functions. Recall from section 1.6 that for all x in domains of f and f to the negative 1, inverse functions have the properties of f to the negative 1 x equals x. So the function of an inverse of that function goes back to x. And the inverse of f of x would equal x too. So both of these are inverses of each other, just like these are inverses of each other. Inverse properties, if negative 1 is less than x and x is less than or equal to 1 and negative pi over 2 is less than or equal to y, which is less than pi over 2, then sine of arc sine x equals x and arc sine of sine y would equal y. If negative 1 is less than or equal to x, is less than or equal to 1, and 0 is less than or equal to y, less than or equal to pi, then cosine of arc cosine x would equal x, and then arc cosine of cosine y would equal y. If x is a real number and negative pi over 2 is less than y and y is less than pi over 2, then arc tan x would equal x, and then arc tan of tan y would equal y. So these are inverses of each other. Keep in mind, and this goes in your notebook class, keep in mind these inverse properties do not apply for arbitrary values of x and y. For instance, arc sine of sine 3 pi over 2 equals arc sine negative 1 equals the negative pi over 2 does not equal 3 pi over 2. In other words, the property arc sine y equals y is not valid for values of y outside the interval. It has to be within this interval here for these properties to pertain. Okay, example 6, using inverse properties. If possible, find the exact value of tan of arc tan negative 5. So because negative 5 lies in the domain of the arctangent function, the inverse property applies, and you have tan of arc tan negative 5 would equal negative 5. And then B, arc sine of sine 5 pi over 3. In this case, 5 pi over 3 does not lie within the range of the arc sine function. Negative pi over 2 less than or equal to y is less than or equal to pi over 2. However, 5 pi over 3 is coterminal with 5 pi over 3 minus 2 pi would equal negative pi over 3, which does lie in the range of the arc sine function. And you have arc sine of sine 5 pi over 3 equals arc sine of negative pi over 3 would equal negative pi over 3. So you could take the coterminal side of 5 pi over 3 and make it work within the arc sine of the sine. Okay, cosine of cosine to the negative 1 pi. The expression cosine of the cosine negative 1 pi is not defined because cosine of negative 1 pi is not defined. Remember that the domain of the inverse cosine function is negative 1, 1. So it's not within that interval. So let's try one down here. Cosine of arc cosine of negative 0.3. And then down here the sine of arc sine negative 0.1. So for up here, it would equal negative 0.3. Cosine of arc cosine negative 3. It is within the interval, so it would become just negative 0.3. Same thing down here would be the negative 0.1. These are within the interval of the arcsine. Finding the exact value, example 7, tan arc cosine 2 over 3. If you let u equal arc cosine 2 over 3, then cosine u would equal 2 over 3. Because cosine u is positive, here is a diagram here of cosine of u 2 over 3. This will be your triangle here. So the cosine of u, because cosine u is positive, u is a first quadrant angle, so it would occur in your first quadrant. You can sketch and label angle u as shown. Consequently, the tan of arc cosine 2 over 3 equals tan u, which equals opposite over adjacent. So in this case, diagramming this out, you can fill in your values here for tan, which is square root 5 over 2, square root 5 over 2. And then for b, cosine of arcsine negative 3 over 5. If you let u equal arcsine of negative 3 over 5, then sine u equals negative 3 over 5. Because sine u is negative, u is a fourth quadrant angle, you can sketch and label angle u as shown. So here's your fourth quadrant diagram of sine of negative 3 over 5. So we get 4 here for this side here. Consequently, cosine of arcsine negative 3 over 5 equals cosine u, which is adjacent over your height. So it would be 4 over 5 would be your solution 1. Use a graphing calculator set in radian mode to graph y equals tan or cosine x as shown. So here would be your graph of that. So when x equals 2 over 3, which is right here, you can use that by using trace and then typing in a value there once you're in trace. When x equals 2 over 3, which equals 0.667, y would equal 1.118, or the square root 5 over 2. So that will be a check. B, using a graphing utility set in radian mode to graph y equals cosine arcsine x as shown. So here, cosine of arcsine x, here will be your cosine of arcsine. This will be how you would type it into your calculator, and then as shown. So this is our cosine of arcsine x. When x equals negative 3 over 5, which would be here, y would equal negative 0.6 in that situation. Here's your y equals, see here, when x equals negative 3 over 5, or negative 0.6, y would equal 0.8. So this would be your y value for your x entry there, which is 4 over 5. So that checks your previous work there. Let's try one now. Find the exact value of the expression. Use a graphing utility to verify your result. So cosine of arcsine 24 over 25. Down here to be the cosecant of arctan of negative 12 over 5. So we're going to let y equal arcsine 24 over 25. Then sine y will be 24 over 25. And cosine y would be 7 over 25. And you would use this diagram here of this triangle that would model this situation here where your sine is 24 over 25. And then you find out your cosine here would be, your adjacent side would be 7 in that situation. And then down here, let u equal arctan negative 12 over 5. Tan u will be negative 12 over 5. And then, so negative pi over 2 will be less than u, then less than 0. So this will be your setup here, cosecant arctan. Let's get a diagram up here of this now. Negative 12 over 5, so negative 12 over 5 for u here. So your cosecant would be 13 over 12 here for this angle here. So that would be your solution here. By using the diagram, you can come up with the cosecant of arctan negative 12 over 5. Example 8. Some problems of calculus. Write each of the following as an algebraic expression in x. So the sine of arc cosine 3x. 0 is less than or equal to x is less than or equal to 1/3. And then b, cotan of arc cosine 3x, 0 less than x, less than 1/3. So if you let u equal arc cosine 3x, then cosine u equals 3x, where negative 1 is less than or equal to 3x, less than or equal to 1, because cosine u equals adjacent over hypotenuse equals 3x over 1. You can sketch a right triangle with acute angle u as shown. This would be the triangle that would satisfy this relationship here in these side measures for this. So this would be u here, our cosine 3x, where we have adjacent here 3x over your hypotenuse, which would be 1. From this triangle, you can easily convert each expression to algebraic form. So again from here, so equal sine over u opposite over the hypotenuse. So we have 1 minus 9x squared after we square this, which would be 0 less than or equal to x, x less than or equal to 1/3. And then b down here, which is cotan of arc cosine 3x equals cotan u adjacent over hypotenuse equals 3x over 1 minus 9x squared. After you square this, that will satisfy this value here underneath your radical. So let's try an example now from that. Sketch a right triangle as demonstrated in example 7. Cotan arctan x. Let y equal arctan x, then tan y equals x, and cotan y equals 1 over x. Same thing down here. Sine arctan x will be sine u, would be opposite over hypotenuse, so you would have this value here for your sine arctan x. It would be x over x squared plus 1. Here's your x over x squared plus 1. Again, up here would be 1 over x for your cotan for this angle here, which would be it would be the adjacent over your over your opposite, which would be the inverse of tan. And that is your lesson for today, 4.7 part 3. Email me here for questions or class worksheets or anything else. Thank you very much.